So we're just looking at the chain rule today. Chain rule is actually kind of simple to use and fairly simple to remember. In the case of a function that's inside of a function, we use the chain rule. So these are two functions that are composed together. 3x minus 7x is placed inside of this function, which is just basically raising it to the power of 5. Now the rate of change of the overall function is going to depend on how fast the outside function is changing times the rate of change of the inside function. So we don't actually have to do a proof for this, but basically what we say is it's equal to the rate of the change of the outside function with respect to the inside function. The inside function's there, times the rate of change of the inside function with respect to x. In other words, we take the derivative of the outside function and we multiply by the derivative of the inside function. Okay, so what does that look like? Well, in this case, u, my inside function, u of x, is equal to 6x minus, oops, sorry, I'm already taking the derivative, 3x squared minus 7x. And my outside function is basically taking u and raising it to the 5th power. So there's my inside function, there's my outside function.
Do we have an inside?
Oh, hey,
Hello.
we're doing the chain rule.
Hi.
Hi there. I mean, hi there.
Hi.
This is Lizzie from Florida.
Lizzie from Florida. You're from Lizzie from Lithuania.
Now from Lithuania.
Yeah, you're from Lithuania now. Where are you guys? Besides Lithuania.
In Vilnius.
So is this the youth exchange conference? Nice. So I'm just doing the chain rule.
The chain rule?
Yeah. Are you up for it?
Yeah, I think I remember it.
All right. Well then, you tell me, what's the derivative there? Are you able to see it?
So that's 5 times 3x squared minus 7x. To the 4th times 6x minus 7.
Very good. So that's the that's the derivative of the outside function with respect to the inside, multiplied by the derivative of the inside function. So that's the chain rule right there. Perfect. So okay, what about this one? Are you there?
Yeah.
Just a minute.
Is this your dad?
Yeah, this is my dad. And also my calculus teacher from last year.
Oh wow.
The calculus class last year had 2 people. And this year it also had 2 people.
Why?
Because our school is that small.
Not many people take calc.
No, I would like a class of 25 people took calculus.
What people normally take?
Math.
What's math?
It's
just, you guys just take math and then it's like math calculus.
So this is actually, this is 1/2 times 3x cubed plus 6 to the exponent negative 1/2 times 9x.
Correct. And what is the slope? Slope at the point where x equals 1?
Three halves.
I think you're right. So f prime at 1 is equal to 1/2 times 3 times 1 cubed plus 6 to the negative 1/2 times 9 times 1 squared. So that's 1/3, 1/9. I think it's just 1.
No, you're like dumb.
Just 1.
I think so. Because it's 1/3. That's 9, right?
1/3 times 9 to the negative 1/2.
Right.
So 1/3 times 1/3.
Times
9. Okay.
Yeah.
I forgot.
Okay. Darn good so far. Okay, there's one last thing that we need to do, and that's differentiate a rational function using the chain rule. Are you good for it?
What are we doing?
We're trying to get away from the quotient rule, so we're going to differentiate a rational function with the chain rule. I'll write it on the board. It'll be very obvious. It's the Friday before the March break. I'm the only guy here.
Nobody came to school today?
Well, RJ was here. He left. So the other Mr. Rogers taught him how to solder electrical stuff yesterday. Anyway,
Sorry?
the other Mr. Rogers,
There's another Mr. Rogers?
there's 2 Mr. Rogers in Lion's Head now.
That's confusing.
No, it's not confusing at all. It's your Uncle Dave.
Oh, I see.
Yeah, anyways, he came and taught RJ how to solder. RJ's like 2 inches away from having his Wi-Fi connected garbage can work. It's pretty exciting, actually. So he did soldering yesterday and got a headache. All right. So you can use the quotient rule here, but instead what we're going to do is use the chain rule. And we're going to turn this into something that's got exponents instead.
So this is actually x squared minus 7 to the exponent negative 1 times 5.
Exactly.
So now it's negative 5 times x squared minus 7 to the exponent negative 2 times 2x.
That's it.
That's all you got?
Well, actually, we could do one more. But it's actually not that much harder.
So that's actually, no, don't go writing y primed yet.
Oh, okay, all right.
That's x squared minus 5x times 9 minus x cubed to the exponent negative 1/2.
Now what?
Now we do 2x times 5 times negative 1/2 times 9 minus x cubed to the exponent negative 3/2 times 3x squared.
Actually, I think you might be wrong. So was the first time. So this is actually a product rule question. Do you remember the product rule? It's yesterday.
Oh, I missed yesterday.
Yeah. You didn't catch the video?
It's not fair.
So if you remember the product rule, you used to sing the song first times the derivative of the second plus the second times the derivative of the first.
Oh, that's going to be a lot of things.
Yeah, it's not too bad.
Okay, so first times the derivative of the second. That will be x squared times 5x times negative 1/2.
Okay, so sorry, that's a minus 5x.
Okay, x squared minus 5x times negative 1/2 times 9 minus x cubed to the exponent negative 3/2 times 3x squared. Times 2x minus 5. Minus 2x. Plus 2x? Okay.
First times the derivative of the second plus
2x minus 5.
derivative of the first. Hey!
Times 9x cubed to the exponent negative 1/2.
Sorry, I'll do that. You're all alone. Well,
I'm not alone.
you're talking
Lizzie from Florida, Reed from Lithuania.
about- Say hi to everyone.
Don't worry about this.
I'll come over here. So.
And, oh, what's this? Here we are.
It kind of just looks like Reed.
No, you gotta come. I can't see you.
I know, but I'm saying, how it just looks like Reed.
Yeah, it's Reed. Lizzie from Florida, somewhere in the background. Somewhere in Vilnius. Look at that.
Alright, go.
It's very disconcerting having the camera there and the computer there. How's your Senate meeting?
I want a coffee. Tomorrow's. So that was exciting.
So Megan's got good news. She killed fruit flies that she wanted to kill.
I go check on them.
Yeah. And so that's about it. The actual question says state the domain and range. So it's one of those things where you can't take the square root of a negative number. So x is going to be greater than, anyways, 9 minus x cubed has to be greater than, or equal to 1. Oh, it has to be greater than 0. So x cubed has to be greater than 9. Oh wait, x cubed has to be less than 9. So x has to be less than the cube root of 9. Anyway, so there's a restriction on the domain. That's it. That's as complicated as it gets. For now, anyway.
For now.
Yeah.